Welcome to Cosmic Compass. Together, we set our sights on the farthest frontiers of the solar system and ask what secrets they hold. In 2015, New Horizons raced past Pluto after nearly a decade in flight. For the first time, we could replace blurry hints with detailed landscapes. What did we find? Frozen silence, or a world full of motion and story? Let's trace the evidence and uncover Pluto as we've never seen it before. On July 14th, 2015, after a 9-year trek through the outer solar system, NASA's New Horizons skimmed past Pluto at roughly 12,500 kilometres. Until that moment, the sharpest global views were little more than blurred colour patches from Hubble. So what did the flyby actually reveal, and what did it prove? On Cosmic Compass, let's follow the evidence together. We'll move from first pixels to full portraits, test what counts as a solid inference, and ask you to weigh each clue with us so by the end we can decide whether Pluto is a static ice ball or a dynamic world with weather geology and a history of its own. Let's begin with the journey. Pluto was the last of the traditional 9 planets to be explored up close. For decades it sat at the edge of our maps, distant and small, and many assumed there wouldn't be much to see. The New Horizons team thought otherwise. Launched in January 2006 as part of NASA's medium-class New Frontiers program, the spacecraft was deliberately lightweight and fast. It reached the moon's distance in just 9 hours, stole speed from Jupiter during a gravity assist the following year, and then slept for most of the cruise to preserve its instruments. As approach day neared, in 2015, the team woke the probe, and we watched a daily drumbeat of images tighten from pixels to patterns. Each new frame made a promise there was more complexity here than the textbooks had prepared us for. Now, to the approach and why we had to wait. At closest pass, the spacecraft's priority was to collect as much science as possible, not to chat with Earth. That meant hours of silence during the flyby. When downlink began, the reality of distance took over a one-way light time of about 4.5 hours and a trickle of data at only a few kilobits per second. If you've ever waited for a slow file to load, you know the feeling. Only this time, the file was an entirely new world. Weeks turned to months as the best images and measurements made their way home. The payoff was worth every minute. Before we dive into surfaces and skies, let's look at the system as a whole. Pluto and its largest moon, Charon, form an unusual pair. Charon is so big and orbits so close that the system's centre of mass, the barycenter, sits outside Pluto itself. Both bodies are tidally locked to each other. If you stood on Pluto beneath Charon's hemisphere, you would see Charon fixed in the same patch of sky, and a viewer on Charon would see Pluto frozen in place as well. That mutual lock is rare and immediately tells us this is no ordinary planet-moon relationship. Add to that, Pluto's small distant moons each, just a few kilometres across, are circling on nearly circular coplanar orbits, and we begin to suspect a past shaped by impacts and long gravitational negotiations. Even visually, Charon looks different, darker, and more muted than Pluto, hinting at distinct origins or divergent surface processing. With that context, let's land our attention on the feature that captured the world's imagination, the bright, heart-shaped expanse on Pluto's face. Its western lobe, Sputnik Planitia, is a vast basin filled with ices dominated by nitrogen with contributions from methane and carbon monoxide. It spans more than 1,000 kilometres and gleams because volatile ices collect and persist there. Look closely and we see the surface broken into giant polygonal cells, broad shallow domes with subtle ridges between them. Those polygons aren't decorative, they're a signature of slow overturning, where warmer ice rises and cooler ice sinks, a kind of convection in a frozen sea. The near absence of impact craters across the plain tells us this surface is geologically young on cosmic timescales. Instead of an ancient static crust, Pluto is resurfacing itself with volatile ice that can creep and flow under the world's frigid temperatures. Around the plane's margins, nitrogen ice behaves the way water ice does on Earth. It flows as glaciers. You can trace these flows as they spill into gaps between mountain blocks and older terrain, filling lowlands and smoothing over earlier scars. The basin's placement on Pluto's globe also matters. It faces roughly away from Charon along the tidal axis, and the weight of its thick ice appears to create a positive gravity anomaly, hints that mass redistribution and tidal torques have worked together over time to settle the basin into its present position. If we want a single exhibit that overturns the Pluto is boring assumption, this is it. Let's widen the view to the high ground. Towering mountain ranges frame portions of Sputnik Planitia. Here, water ice acts as bedrock. At Pluto's average surface temperature, around minus 229 degrees Celsius, water ice is as rigid as rock, strong enough to buttress peaks several kilometres tall. Among the standouts is Right Mons, a broad edifice with a central depression rising roughly 4 kilometres above its surroundings. The geometry and texture make it a candidate cryovolcano, not a classical volcano of molten rock, but a vent where slurries of volatile ices may have once welled up and spilled across the surface. We should be cautious, candidate is the right word, but even the possibility lifts Pluto into a small club of worlds where internal heat still shapes the exterior. Not all of Pluto is bright. As we follow the equatorial belt westward, a dark, sprawling region called Cthulhu Macula stretches almost like a shadow thrown across the globe. This is older ground heavily cratered with a surface thought to be darkened by tholins, complex hydrocarbons cooked by sunlight and radiation. Against that darkness, sharp-edged mountain ridges stand out, often topped with methane frost. Methane prefers high ground here, condensing as a delicate veneer where temperatures and winds allow. The contrast is striking, pale summits on a sable plain, a reminder that even in deep cold chemistry and microclimate carve out niches. To the east lies one of Pluto's strangest textures, Tartarus Dorsa, a region that from orbit looks like braided bark or coiled snakeskin. The relief is real rows of narrow blade-like ridges rising hundreds of metres. One interpretation is that these are penitentes, spiky landforms that on Earth grow where intense sunlight sublimates ice, unevenly sharpening troughs and leaving thin fins behind. If so, Pluto would be the only other place in the solar system where they have been identified, and on a vastly grander scale. Whether by penitents or another process unique to Pluto's climate, the message is the same surface ice here is sculpted not just by impacts and flows, but by the precise dance of sunlight in an ultra-thin atmosphere. And that brings us to the skies, the most surprising proof that Pluto is in its own way alive. Pluto has an atmosphere. It's tenuous by earthly standards, with surface pressures in the microbar range, but it reaches far above the ground and it changes with the seasons. The ingredients echo what we see on the surface: nitrogen in the lead, with methane and carbon monoxide as important players. Against backlit views, the atmosphere announces itself with grace. We can see up to 20 distinct haze layers ringing the planet, like the lines of a topographic map drawn in the air. These layers aren't simple horizontal shells. In some images, a layer that floats high over the terrain on one side swoops down to kiss the surface on the other. Mountains cast long shadows through the mist, and sunbeams slant between the strata, revealing a vertical structure more intricate than anyone anticipated. Let's ask what those layers mean. Haze forms when sunlight cracks methane and other molecules in the upper atmosphere, building complex hydrocarbons that clump into tiny particles. Those particles settle, and in Pluto's weak gravity and thin air, they can drift and stack into sheets that trace waves, winds, and terrain. Seasonal cycles matter too. As Pluto moves along its long elliptical orbit and tips its tilted axis through long winters and summers sublimate from one hemisphere and recondense on the other. That migration shifts surface pressure and drives circulation. Observations suggest Pluto's atmospheric density can vary significantly over relatively short times, and the distribution of surface frost responds in kind. Some scientists have even pointed to shapes that look like a frozen shoreline in one basin and asked whether under different past pressures and temperatures, nitrogen might have briefly pooled as a liquid before freezing. Others argue the conditions would never quite cross that threshold. For now, it's a live question, and a useful one because it forces us to fit every spectacular image into a consistent physical story. Why does any of this matter? Because each clue overturns an assumption. The Pluto-Charon binary challenges our tidy categories of planet and moon and hints at a violent origin. Sputnik Planitia's convection tells us that even far from the sun, volatile ices can keep a world's surface young. Candidate cryovolcanoes point inward toward heat that still moves. Dark tholin fields and methane frosts show chemistry shaping climate and landscape in feedback. Layered hazes reveal an atmosphere with structure and memory sensitive to the slow seasons of a distant orbit. Taken together, they transform Pluto from a footnote into a case study in planetary diversity. Where do we go from here after Pluto New Horizons continued deeper into the Kuiper Belt and on the first day of 2019 flew past a small contact binary now known as Arrokoth, an object that preserves the earliest stages of planet building? That story deserves its own episode, and we'll get there. For today, let's close with the promise that drove a spacecraft across billions of kilometers. When we reserve judgment and let the evidence lead, even a faint cold point of light can open into a world. If you've learned something new, stay with us. On Cosmic Compass, we'll keep asking better questions, following better data, and inviting you to decide with us what the solar system is really like. Pluto turned out to be anything but lifeless. From its strange partnership with Charon to the vast nitrogen heart, from mountains built of water ice to hazes layered high in the sky, every discovery reminded us that distance does not mean dullness. And New Horizons didn't stop there. On the first day of 2019, it met Arrokoth, an even more primitive relic of planet formation. That journey deserves a story of its own, and we'll explore it soon. If you've enjoyed traveling with us today, stay with Cosmic Compass. Subscribe, join us for the next expedition, and together, let's keep asking better questions about the universe.